First of all, let me introduce Dr. Ameet Joshi. So, Dr. Ameet Joshi is basically a very renowned person in his field, especially. So, he did his PhD from Michigan State University. He has worked in a variety of different fields such as oil and gas industry, home energy, automation, and many of the AI projects that are being done at Microsoft. He's currently data science manager at Microsoft. Yeah, and not only that, he has also written numerous publications. And there is a book which he has written, which is on machine learning and artificial intelligence, which is published by Springer. And Springer is, like one of the most renowned publication in scientific world. And it was the most downloaded book in 2020. So I think we are really honored to have a guest like Dr. Ameet Joshi, and we are really thankful that he agreed and has bestowed us with a privilege to be in his company. So without any further delay, I think hi, Dr. Ameet.
Hello, Ashutosh, and hello, everyone, all the students and parents.
I'm not able to hear you.
Oh.
Yeah, I can hear you. Sorry.
You can hear me? Okay. Yeah. Hello, everyone. And thank you, Ashutosh, for the introduction. And yeah, I mean, I have been in this field for a long time, and but it is really a very unique opportunity, I think, for me to talk to the next generation of students who are going to actually, take this current status of machine learning forward and usher into the future era of machine learning. So I would really like to, talk to you, share my thoughts, answer your questions, and, have any in general conversation with you. So really looking forward to.
So thank you, Amit. So just for everyone, so during registration itself, we have gotten a lot of questions from students, and we have summarized them into few of the questions that we think will encompass all these questions that have been asked by students. So I think the first question that I would like to ask on the behalf of our students. So one very basic question asked by a very young student was basically, what is machine learning, and how is it different from artificial intelligence? What that means is basically a lot of people hear machine learning, artificial intelligence, and it is very difficult for them to understand what is the difference. They both seem very same in terms of their application. So I think if you can elaborate about what is machine learning and how is it different from artificial intelligence.
Yeah, that's a great question. And you are absolutely right. In general, in the literature or in the context of this field, machine learning or ML and artificial intelligence or AI, these words are used almost interchangeably. And then, but there are very different key terms involved in that, and one can easily get confused. So to start with, machine learning has come more from a technical origin. So this comes from computer science and some electrical engineering, image processing, etc. These areas. And so the term machine learning primarily, focuses on the algorithms, the techniques that are used to make the machines. And in general, when we talk about machines in this context, we are referring to some form of computer. So some form of like a device that can process data and generate some kind of output. So typical examples are like our desktop, laptops, smartphones. But along with that, there are many other devices now that are also can be considered as machines in this context. Like, we have drones, they have processors and video cameras on them, robots, obviously. And also some like, televisions, they have smart features, even some cases, refrigerators and so on. And the list just goes on and on. So all these devices that can process information can be called as machines. And the learning part is basically where there is some form of algorithm or technique that is happening on that device or machine that makes it interact with the environment. So that's the kind of machine learning encompasses. And then let's come to artificial intelligence. Now, artificial intelligence as a term is actually older than machine learning. So in 1950s, there was a famous computer scientist, Alan Turing. He first defined what AI is. And his definition was very interesting. So his definition was very much focused on human-like intelligence. So he essentially said that if there is a curtain, and behind the curtain there is some device, and a human is interacting with that device, it can be through keyboard or through oral conversation, and the device is responding back. And if the human feels that the responses that he is getting behind the curtain are intelligent, then that is artificial intelligence. So that's how he defined it. But later on, that definition kind of changed in 90s, where it was more of an expert system. And now in 21st century, with advent of deep learning and a lot of other techniques, again that definition is changing, and it's actually coming back to the original definition of human-like intelligence. So to in general summarize this, machine learning is kind of the techniques or the technology that powers the experiences, which are called as artificially intelligent experiences or AI in general.
Thank you so much, Dr. Amit, to explain and demystify what is the difference between machine learning and AI. I think if I have to summarize, what we can say is that machine learning is basically kind of like a backend, and what we experience or what we interact with is AI. Right?
Yeah.
I think moving on to next question. So the next question was asked by a student who is interested in understanding how machine learning is related to coding, as in how a tool like machine learning can be used to make robots or code robots. So that's the next question that I would like to ask you.
Yeah, sure. Yeah, this is a very interesting question. So the way coding or in general software engineering became like extremely popular in I would say from 90s, almost from like 80s, 90s, and really took a strong hold around 21st century. What I feel is that the entire genre of software engineering will soon be replaced by machine learning. So like don't get me wrong, software is still going to be needed, because there are a lot of different areas where you don't really need machine learning type techniques. But what has happened over last couple of decades is that all the software components that used to be written manually are now already like automated and compartmentalized into like modules that you can just call. To give you an example, I remember when I was in college in 90s, if you just want to write a simple program to open like a window and has just basic menu like file, open, etc., you'll have to write like thousands of lines of code just to have that particular window. But now, if you come to the latest versions of C# or C++, there are so many things that are automated that you can just call certain classes and initialize, and like within like 5 lines of code, you have the similar window and some functionality already in that. So to basically take from that is like a lot of efforts that were required to develop certain applications in software. The efforts that are required are getting smaller and smaller. And what is more important after you have that piece of software is to make that smart. And that's where the machine learning comes in. So and machine learning, it builds on software. So in order to do any type of coding that is required in machine learning, you absolutely need to understand the basic concepts in software, like how in general the command statement, all the different if statements and loops and all those things, those are like still building blocks. But you go on top of that and you build specific components that make things smarter. So coding is definitely the starting point, but more and more focus, I think, will go to machine learning in the future.
Okay, just to, I think that's a great answer. What I wanted to basically like emphasize here is that perhaps if a lot of coding will be done through machine learning, what we will have to think of is perhaps what is the, like what we'll have to provide is a pseudocode or the algorithm behind the problem that we want to solve, and the computer can itself code. That's right.
Yeah.
Moving on to the next question. So the next question was also basically asked by a very young student who is asking basically that, what is the usage of machine learning, right? We see and hear so much about machine learning. How is it affecting our day-to-day life, and how will it be able to make our day-to-day life easier in future?
Yeah, that's a great question. So, ultimately, what is the use of machine learning, right? Why it is becoming popular and getting all the attention these days? So it is for obvious reasons. So, coming again back to the software engineering, machine learning differences. So software provides capability of processing information on machines, but that processing is deterministic. Like, whoever is the person who is coding the software, he anticipates all the different cases that will happen and then codes what the machine will do for those. While machine learning takes it a notch further, where the machine can now take some actions that are not even known to the programmer or to the person who coded that particular piece of software. So that's kind of, with that we can enable a lot of intelligent experiences. And the AI, we are already seeing so much in our day-to-day life that we are even unaware that we are actually interacting with something that is intelligent. To give you a simple example, when we are browsing websites, we see a lot of ads. These ads are personalized, so every person, based on his previous search history or whatever other website that he has visited, is going to see different ads than the other person who has a completely different browsing history. So that is one thing. Then we have these smart speakers like Alexa, Siri, Cortana, and so on. So those are like, you ask questions and they can answer like a conversation. So that's that's obvious, I would say, use of AI. But then there are many other cases, like, we also have seen these vacuum cleaning robots, Roomba, or some other variants of that. So they can actually understand your layout of your room, and automatically scan and clean your entire room, and so on. So like that, many more appliances are now going to get these smart chips and become intelligent. Now we already have lights that you can turn on and off by commands. And like TVs are already smart TVs, and so a lot of different appliances. So actually Satya Nadella, he once called that as ambient intelligence. So it's basically, we are going to be around in an environment that will be alive, that will be intelligent, and will be reacting to our actions. So yeah, I mean, the future of AI is really, there is you whatever you can imagine, that is the limit. It's pretty much like that. And currently it is coming mostly from the technological area, so that's where it is primarily getting applied. But I think the real future lies in use of these techniques in completely non-technical fields, like agriculture and other heavy industries, or whatever arts you can imagine. Whatever you can imagine, you can find some use of AI to make our lives easier, and like enrich our lives.
Certainly, I think that was a great answer, Dr. Amit. Definitely, I mean, we are all experiencing for example, I mean, all of us must have experienced something like how great YouTube recommendation works. Like if you click on a video based on your interest, then YouTube just knows that, what is the next video that it can recommend that you will watch.
Yep.
I mean, there are many, many more examples. I think we'll move on to the next question. So the next question that was asked by a student was basically, so we are experiencing ML in current times. So, but what do you think, will be the future advancements of machine learning? Where do you think, machine learning will be headed in future, in the next 5 or 10 years, or maybe, beyond as well? So if you could
Um,
answer and tell us.
Yeah, that's a great question. And again, continuing from some earlier discussion, where the ML will go, and what are the different applications of ML that we can see or we would like to do, build ourselves. That's really in our hands. And so here I would like to point out one more thing that, and kind of is a dialogue from Spider-Man movie, that with more power comes more responsibility. And AI is really giving us tremendous amount of power that we don't even realize at many times, that the potential of things we can do with AI. And as Ashutosh was saying, the YouTube videos, like you just play one song and it kind of automatically creates a playlist based on that. Similarly, on Netflix, you kind of it customizes the whole experience based on your previous watchings. There is also, like in images, like you keep taking photos and then Google Photos like automatically identifies the people in that, and then places and so on, and you can search based on that. So the kind of the reach is really vast. But what we really need to understand over here is that we need to be responsible in our use of this technology. Just to give you some like examples, so there was one company, I won't say the name, but it was in the news that they had like a very powerful image processing software, and then whenever you kind of upload a photo, it will identify which person that is, and based on your friends and relatives and so on, and will automatically label that. And when one black lady was trying to do that, unfortunately her friend's photos were identified as gorillas. And she was really disappointed, and she tried to take in like some better lighting or something. It didn't really help. And ultimately the company realized the mistake. And the problem here was that the data that was used, the images that were used for training their algorithm, contained only primarily white or Asian people, and it did not have a good representation from black people. And as a result, the model was not as good in identifying those people. So we need to understand that machines can be smart, but they are only as smart as we can make them. So they are learning from the data that they are seeing. It is actually very much like us. Like if we are only living in one part of the world and we suddenly see completely different people, like somebody like an alien, we are just going to be freaking out, right? So that's exactly what happens with the computer models as well. Like if they have not seen a certain amount type of data, when that data is encountered, they just basically give some random answers. And so it is very important to be inclusive and responsible when we are building any machine learning application. So the models are, the algorithms are very smart. They are built using a sophisticated mathematics, but ultimately the data that is provided to the machines is really the important part. And when we are building machine learning models, it is very important to select that data very carefully. It should represent all the different situations that will happen, not just when we are training, but when we are actually deploying this, and other people, everybody in the world is going to use that. So that's one thing that I would really like to emphasize about. And that thing is being recognized so much that there is a big push in the AI community about responsible AI and ethics. So it's kind of a completely different field if you think about it, but they need to work together in order to provide a better experience to everybody on earth. Like these Hollywood movies, they do a great job in making these technologies popular, but they also have this kind of villainous kind of take on AI, where AI will try to kill the humans and so on. I think that's a bit far-fetched and very unlikely to happen, but it's very likely to happen that the AI that is built by humans can cause problems to humans. It's like make their life harder than easier if they are not implemented correctly. So that's the responsibility that we have. But as far as potential is concerned, it's really limitless. It's like a wherever we want to make things easier, we can apply machine learning techniques, and it will help.
Yeah, I think that reminds me of a documentary that I was watching on Netflix. It's called Coded Bias, where it actually talks about that uh, the code that the model that you create, or the computer program that you create, always had an embedded bias, by the coder, right? And that's why it is very important that even in the coding community, there is representation of each and every representation of various people from various communities, whether it is a socio-economic background or various race, and whatever are whichever communities need representation in tech. Otherwise, this can really lead to discrimination by the technology itself. So I think I also wanted to ask you about so machine learning has moved forward, but one thing that we keep hearing about is also deep learning, right? Something that very recently it has happened, and I mean, if you can elaborate further upon that.
Yeah, absolutely. Yeah, I mean, that we cannot complete any discussion about machine learning without talking deep learning these days. Before going into deep learning, I would like to touch upon one specific technique in ML, and that's neural networks. So I am sure, all of you must have heard about that. But surprisingly, the actual concept of neural network is actually one of the oldest in machine learning. So neural networks were introduced almost in 50s and 60s, and in AT&T labs they actually had implemented a very rudimentary form of neural networks. Used to occupy huge buildings. That computers were that big at that time that it was taking a lot of space. So it was basically inspired by human brain, like the way the neurons in our brain work. They were trying to imitate that kind of behavior. So each single neuron is basically has one or more inputs and a single output, and whatever information or data we are passing in, it basically gives you output as just 1 or 0. And if you want to do a simple classification, like you want to classify two flowers, between sunflower and rose, you can just give input as a color, and then whenever the color is red, it will be 1, which meaning rose, and if the color is yellow, then it will be 0, meaning sunflower. So a simple neuron can do a simple classification. But if you want to say classify 3 flowers, then one neuron is not going to be sufficient. Then you will need 2 neurons, and then you can have 1 and 0 as one and 1 as second flower, and say 0 and 1 as third flower, and so on. So as the complexity of the problem increases, you can just keep adding more and more neurons, and that becomes your neural network. And then you can have multiple layers of neurons. Like there is an input layer which can contain hundreds of neurons, and then there is an output layer which can contain maybe 5 neurons, depending on how many different things you want to classify or predict. And then if the problem is complicated, then you can add some intermediate layers of neurons, and then you can essentially, it lets you model a lot more complex problems. But what happened is that in the early 1950s and 60s, when this particular idea was introduced, the hardware that was used in computers was so basic and so slow that the real potential of the technique was just didn't realize. And it was only able to solve very simple problems. And whenever there were more complicated problems like image processing and all, neural networks just didn't work. And at the same time, there were many different techniques that were coming from other areas, like decision trees, support vector machines, and you might have heard these words, and many more, reinforcement learning. And they were instantly way better in performance than neural networks. And neural networks actually almost died in popularity. But around 21st century, around 2004, 2008, that time NVIDIA came up with a new technique where they were using the graphic processing units, which we call GPU in the computer, as a regular processor for machine learning applications. Now, a typical processor in a computer used to have only a one single core. Nowadays, it can have like 5, 6, sometimes even 8 cores. But that's the max it can have. But graphics processing units typically has thousands of cores. Now, individual core in that is not as powerful, but collectively, if you can process the information in parallel, that's way more processing power than a processor, like order of magnitude better. And by using those, by leveraging those processors properly, the machine learning applications became suddenly so fast that some of the processing that used to take like days can be completed in like hours or minutes. And that kind of order of magnitude jump really helped to enable the neural networks to come back, because now with the available of huge amount of memory, because memory is also becoming cheap, and like you every day you see that more RAM, more hard disk, something that used to be in megabytes is now gigabytes, even terabytes. We have that kind of huge memory and also the processing power, and collectively that really made neural networks possible again. And now it's the deep learning essentially is still underlying neural network. So it's kind of a different name they gave, because just neural network was kind of a failed technology, olden times. So they kind of started calling it deep learning, but it's essentially neural network technique with a very very long and complicated network with hundreds of neurons and maybe 10 different layers, and a lot of complexity in that. But at heart, it is still neural networks. But with the new processing power and memory and the advanced algorithms, you can really process like a large amount of data and generate whatever output you want. And the advantage of deep learning or neural networks compared to all the other techniques is that the same neural network can be trained for any application. Like previously, if you want to use say support vector machine, then you can only do classification, for example. It cannot be used for some other techniques, while neural network is not limited by that. It can do classification, it can do prediction, it can do interactive learning, whatever kind of experience you want to generate, you can do it with neural networks. And that's essentially what the deep learning lets you do. But it is, again, double-edged sword, in the sense, if you want to really get the best performance out of them, you need a lot of data. So one thing you need to realize, the more complex the model is, the more data you need to train that. So, in order to train the deep learning, you need like hundreds of thousands or millions of samples. And then it will do really great on that. And it will be really, really good in predicting the, whatever you want to do.
I think that has given us a lot of leap into the future of machine learning and how it could, be developing into a much more bigger technology where you just have to give the input and there will be an output, right? I think we have been getting a lot of questions from the students in Q&A. I think a lot of questions are quite similar. So I think I'll just ask one of the questions that I feel is going to cover a lot of questions asked by students. So what they're asking is basically, if someone like them, wants to learn machine learning, what is the right way to do it? What is the language that they can, choose to learn it? And basically, what could be the future prospect after learning machine learning?
Yeah, that's a great practical question. And I would be, it's really important. I mean, it's like all great. It can be used everywhere, but, like how exactly am I going to do it, right? So, yes. So machine learning, as I said, it kind of really builds on, standard coding. So you can do machine learning in C, C++, Java, but these are kind of, a little bit lower level languages where, you will have to like start from scratch, and you have to write a lot of algorithms yourself. So the programming languages that are really popular in machine learning field are Python and R. Also there are some like premium packages like MATLAB, or there may be some others, but Python and R are more like in a free kind of a domain. And Python is becoming really more popular, and it is getting more and more support from all the community, because ultimately machine learning is a cutting edge in technology. So all the universities, they are working on developing new techniques, and whatever language they use, it's better to stay with that, so that you can immediately get the latest and use it. So from that perspective, I would say Python is probably the number one choice. Now Python as a language is actually not as efficient as C or Java, where those are called as compiled languages, where entire code that you write is kind of compiled and is optimized to run. So the same code, if you write in C and Python, the C code is going to run faster. But when we are talking about machine learning, it's already going to take very long time, and you need a very powerful hardware to do that. So it is less important. But if you want to write the same code in C that you can in Python in like a matter of half an hour, it will take you like days. So that time saved is a lot more important than some optimization. So Python is pretty much like the de facto standard. And there are a lot of open source libraries that you can use. One of them I would like to mention is called scikit-learn, or sklearn. And so you can just install it. There are different packages that you can choose to do that. And then it's essentially all you need is basic fundamentals of Python, like how to like import different libraries, and then basic data structures, and the basic constructs in Python. And you would be like moving to build your first ML program with that.
I think thank you so much for answering a question that I think there are a lot of students who have in Codeyoung especially. So I think that will definitely help them to understand which language they can prefer. I mean, it's quite apparent that Python is one of the most widely language, and since it's one of the most widely used language, a lot of people who are working in something in an interesting field, like or who want to work in an interesting field like machine learning, are going to choose a language which is very easy to interact with the computer, right?
Yep.
Perhaps. So now I think we'll move on to the next question. So basically, the next question is basically about where do you think will be like, so far we have seen that AI as machine learning has been applied in for example e-commerce, or or on advertisement, and few other fields we have seen. But where do you think it could be applied in future? For example, when what do you say, industrial revolution happened, the first industry was basically machinery, right? Then we saw that happening into construction, and then automotive industry. Then we started seeing that like, for example, so like today, for example, nobody in America especially uses like hand tools, right? Nobody uses like non-machining tools. Everyone uses a machine to do something simple as agriculture, right? So that's how, like, from industrial evolution we have come down to this point. So where do you think what are the fields that will see encroachment or advance like application of machine learning in future?
Yeah, that's a great question. So it's like as I said, this machine learning AI kind of is a very techie kind of a field, and the people who are involved came from that background. So obviously, computer related fields were the first one where this technology is deployed, and it's currently used heavily. Also, like and again, coming back to the roots, the real power of AI lies in the cases where we want to generate something that can work in situations that are not even anticipated by us, right? So that is the most important part. Like and it's really interesting that you mentioned about industrial revolution. So that happened something around 18th century, and that really changed the life of pretty much the entire world. And anything that was as big as that had happened almost like 3,000-4,000 years before, where the humans started farming. Before that, they're like hunter gatherers and like just moving around the world. Like organized farming was the first, I think, biggest change in human life. And after that, almost like few thousand years, we had industrial revolution, where that again had a similar level of impact. And I think we are only like 300 or so years from that point, and we are already seeing something as big as that, because the AI and ML has the power to change our lives almost to the extent that our lives were changed with the industrial revolution. Because now we are going to enable things that we don't even like plan for. Like for example, when we launched this rover that went to Mars, like nobody has even gone to Mars, right? We have only seen some photos, so we don't know exactly what kind of terrain to expect. Like how hard are the rocks, like what are any different things that are on the surface that will make the car slide or fall or not move or get stuck. I mean, there are like so many uncertainties that we had no clue. But in spite of that, that rover somehow was able to navigate, maneuver on that planet, collect samples, and like do a lot of things over there. So that was only possible because some form of AI that was built in. So like if we can go to the other planet and do stuff over there, like it's just, we can imagine what we can do on our planet. Like we can go to the bottom of the oceans and study whatever we can, where previously going into like humans, sending humans over there was not possible. Like and then also like a lot of hazardous places, like nuclear reactors and so on, where it is very difficult to like dangerous for humans to go and do anything cleanup work or whatever work that is needed. We can just deploy robots that can interact on the fly to unexpected situations and do the job. Similarly, like in military and in unfortunately in warfare also it can be used. I mean, again, that's, as I said, right, with power comes responsibility. So it's really up to us how to use the technology to better our lives, enrich our lives. So as I said, all the other areas that are non-technical, I think are nascent fields and really, really present all of you a huge scope to do something. Because anything that you do in arts, for that matter, right, it will be something completely groundbreaking and new, and you can have a startup and you can have like your own mark with that. So if you are good at AI and you move your focus to any other non-technical fields, I think you can start finding applications of ML like every minute, and you can really make some huge progress by making that application there.
Yeah, I think that was a great answer, Amit. I think what we can say is basically we have to understand that what are the kind of like tasks that we are doing, but are kind of repetitive in nature, and maybe if we train a machine to do that, it can, with time, maybe not, right now it might not be able to, but with time it will be able to do it as it learns further and further, right? I think so one question that we just got in a like few some time ago is basically, what do you think are the limitations of machine learning? I mean, that is a very interesting question though. Like everyone talks about the possibility, or what a machine learning can do. I think it is very difficult to realize what it cannot do.
That is a really great question, and so typically I like to answer this question with one caveat. Is do you know what you don't know, or if you don't know what you don't know? So it's like two levels of not knowing things. So I'll give you an example. Like you have a problem where you want to classify the images into cars and buses, for example. Okay, so but you don't know how to do it, right? So this is a problem where you know what you don't know. Okay, so I know that I want to classify buses and cars, but I don't know how to do it. These type of problems, okay, we can totally solve with machine learning. So all you need to do is you need to get a lot of data and then you label it, like, you kind of just say, oh, this is car, this is bus, this is car, this is bus, and just give that data to the machine learning model, and it will learn how to do it. But when you have a problem about that you don't even know that exists, that's where the real problem lies. Like, if you want to say that, okay, I want to eliminate cancer. Okay, so kind of, you have the problem definition, but you have absolutely no idea how to even tackle it. So this is the cases where machine learning may not be able to help. So, but the thing is that you can start with this situation, but then if you can do so, that's where, see, that's a very important thing. Like, the machine learning has limitations, and that is very important, because if it did not, then actually the Terminator 2 can be real. Like, if machines can really solve anything, then they will overtake us. But that's not going to happen, and that's a good thing. So machine learning also has limitations. It really depends on what data we present, and what problem we tell it to solve. So it is not going to create its own problem. Like, the machine learning model is not going to create its own problem and then solve it. It should be given a problem and data, and then it can solve it. So it is still, it is one step, definitely a huge step forward from industrial revolution, where everything that was machines were doing is like, put it here to here, or screw this, some like really repetitive and non-intelligent tasks that can be improved with machine learning. But still, the problem will be still given by humans. So we will actually define the problem, we'll limit the scope of the problem, and based on that we will give some training data to the model, and then it will learn from that. So so as long as we know what we want to do, machines, we can train machines to do it. But machines are not going to do something on their own. So that's I think the limitation of machine learning. But it's still like, with that, it actually has a huge scope. I mean, as long as you know your problem and you can gather some data around it, ML can help.
I think that's a great answer. I think what that probably tells me is that what we as a human have to do is develop an ability to ask questions first of all, and develop an ability to break down a very complex problem into multiple questions, and then feed those questions to the machine, which is very powerful, and then it can give us the right answers that we like. That would be the solution to the actual complex problem we thought of, perhaps.
Yep.
But it will very, very much depend upon the coder itself again, right?
Yes.
Yeah. I think we have pretty much like run out of time, but I think we will definitely, I hope all the students really, really, enjoyed this talk. And I also thank all the students and parents who have joined us in this talk. I also thank Dr. Ameet Joshi, who has taken out a precious time from his weekend actually, and been there for us in this early morning, perhaps in US, and many of the other students who have joined us as well. So I have just small and couple of announcements for Code Olympics for all the students here. So basically, we are going to close Coder of the Week this weekend, that is by the end of the Sunday, and we will be closing the basically deadline for Coding Carnival for Scratch, MIT, and WebT is 31st October, and the Coding Carnival for Python will be on 31st October, which will be live on a hackathon platform called HackerRank. And one final announcement for all the students is that, just a second, I forgot. Yeah, so basically we will be sharing a feedback form we'll be sharing a feedback form in the chat. If you have any suggestions, all the parents and students, or anyone who has any suggestions for us, definitely send us your suggestions. We will try our best and work hard to incorporate your suggestions and make this code talk much more relevant and useful for all the students and parents as well. Thank you so much, Amit, and thank you, everyone.
My pleasure. Thank you.